Example 11, page 66 of the C3 textbook, we're going to look at integrating trig functions. Now, let's remember what we know. We know the differential of sine x is cos x. The differential of cos x is your minus sine x. And differential of tan x is sec squared x. Now what that means is if I have to integrate cos x, I'll get sine x. If I have to integrate sine x, I'll get minus cos x. And if I have to integrate sec squared, I'll get tan x, as integration is the reverse of differentiation. Okay, so for the first question, I have to integrate sine 5x. This is going to be something around here, because I've got sine x on this side. So it's going to be something about cos. So we're going to consider cos, and because it's sine 5x, we're going to consider cos 5x, first of all. But when we differentiate this, if I differentiated cos of 5x, I'm going to get minus 5 sine 5x using chain rule from the previous slides. That's not quite what I want. I want just sine of 5x. So how do I get from this to this? Well, I'd have to divide by minus 5. So if I divide this by minus 5, I'd then divide this by minus 5, this by minus 5, and I'd get sine of 5x, which is what I want. Therefore, the integral of sine 5x with respect to x is minus a fifth of cos 5x. Might seem a bit confusing at first, but things to note are, first of all, we're looking at this sine, and it's going to cos. Instead of x, we've got 5x, so it's going to go to cos 5x. When this is negative, this is positive, therefore if this is positive, that's negative, it changes sign. That's where we've got our minus sign from. And because it's 5x here, we have to divide the whole thing by 5. So if you differentiated it, it would multiply by 5 and cancel out. Okay. I've obviously made a little bit of a mistake here in the sense that I should have plus c for my constant of integration. Don't forget that. Okay, let's look at the second part of the example. Okay, for part B, we're asked to integrate sec squared. So sec squared's here, so it's going to be something to do with tan. Instead of integrating sec squared x, we're integrating sec squared 3x plus 2, so we're going to consider tan of 3x plus 2. Okay, that's what we're going to consider. Now if I differentiated that, I'd have y equaled tan of u equals 3x plus 2, du by dx is 3, dy by du is sec squared u, which is sec squared 3x plus 2. So you'd have that dy by dx is the product of this and this, which is 3 sec squared 3x plus 2, which isn't quite what I want. I want just sec squared 3x plus 2, so I'd have to divide it all by 3. So I know that the integral of this is going to be a third of this plus c. Okay, let's look at part C now. Okay, this might look rather disgusting this time, but it's not as hard as what you might think. Again, because it's cos, we look at cos, which would differentiate to sine. So we're going to consider sine of x cubed this time. Sine x cubed. Now if you use the chain rule to differentiate this, if you did d by dx of this, using your chain rule, you're going to get 3x squared cos x cubed, which is almost what you want here. You want a third of this, so you'd want that over 3, so you'd want to have a third, the integral would be a third of sine x cubed plus some constant. Okay. Now, in general, the following holds true. The integral of cos kx, where k is any integer, any number, in fact, any fraction at all, if you integrate it with respect to x, you're going to get 1 over k sine kx plus c. What this means, if, for example, you had the integral of cos 5x with respect to x, that would be 1 over 5 sine 5x plus c. Okay, that's a specific case. So in general, this is true. And additionally, the integral of sine kx with respect to x is 1 minus 1 over k cos kx plus c. Now these that I've boxed in, you'll need to memorise these two, knowing that when you integrate cos, some value k here, you get 1 over k sine kx plus c. Integrate sine, similar, except it's the negatory one. Negative. Okay.